In our last class, I said energy is the ability and capability to do work. So we have different types of energy. We have under mechanical energy. We have mechanical energy. We have potential energy, and we have kinetic energy. So these are the two types. And I also told you that potential energy, the formula is mgh, and the formula for kinetic energy is half mv square. So that's the first part that I explained to you in our last class. Now we'll be going to the various applications. We have a question here now. A body of mass 20 kilogram is raised to a height of 2 meters above the ground. What is the potential energy? So the first thing, like I said, anytime you're solving any question in physics, say a body of mass 50 kilograms. So you write the parameters. M, mass is 50 kilograms. Then the height, they gave you the height to be 2 meters. Then the acceleration due to gravity already is 10 meter per second square. So for you to work on this now, you have to use P equal to mgh. So if P is equal to mgh, you are going to just multiply 10 by 2 and multiply it by 50. So take note of this formula I want to give to you now. We have power is equal to work done over time taken. So also take note that power is also equal to energy expended. Power is also equal to energy expended over time taken. So in this place that we are saying power is equal to work done. So work done is what? Work is force times distance over time. So or power, energy expended, which can be potential or kinetic, mgh over t. So in this case we have force times s over t, where we said that it's going to give us P equal to F times what? What's distance over time? Distance over time is velocity. So we have that P equal to FV. That's the first part. So we can have P equal to FV or P equal to mgh over T. You understand? So we have P equal to FV or P equal to mgh over what? T. Take note of this point very well. P equal to force times velocity. So you just write here F equal to force, V equal to velocity, M equal to mass, G equal to acceleration due to gravity, H equal to height, and T equal to time. So we have T is time, G acceleration due to gravity, H which is height, M which is mass, F which is force, and V which is velocity. Yeah, good afternoon or good evening. Sit down. So we have the question here which says a car traveling at 60 meters per second produces a force of 400 Newton. Calculates the power of the engine in kilowatts. So how do we go about that? The first thing we are going to take note of is we're giving velocity to be 60 meters per second. We're giving force to be 400 Newton. So we have this velocity to be 60 meters per second. Then we have force to be 400 Newton. Now the first thing to take note of, we said power is equal to work done over time taken, which is force times distance over time, which we said that power is equal to force times s over t, which is force times velocity. And we said that if it is force times velocity, we can check. Well, let's check our parameters here. Now you see the parameter here. We have v equal to 60 meters per second. So you just come here and write 60 meters per second. Then you see the force here to be 400 Newton. So you come here and write 400 Newton. Now 400 times 60 giving us 24,000 watts. 24,000 watts. Now we have gotten the power to be in watts, but they told us let the power be in kilowatts. How will you calculate it in kilowatts? To give you power is equal to 24,000 divided by 1,000. So 24,000 divided by 1,000. You see all these zeros cancel each other. So we have our power to be 24 kilowatts. 24 kilowatts. The question we have here is calculate the power of a pump which can lift 200 kilograms of water using a vertical height of 6 meters in 20 seconds. So how are we going to go about this now? I will explain. The first thing is we need to write down our parameters. So our parameters, the first one we're giving is mass to be 200 kilograms. The next thing is we're giving height to be 6 meters, and we're giving time to be 20 seconds. Then we're giving acceleration due to gravity to be 10 meters per second. So first things first, you need to understand that power is equal to energy expended. Power is equal to energy expended over time taken. So power can either be energy expended over time taken or work done over time. So if this is the case, what's the next step? You just have to take note that the energy expended can be mgh over t. And what's mgh here? Mgh is 200 times g, which is 10 meters per second. Then we have h, which is 6 over t, which is 20. So we have 0, 0, 2 here 1, 2 into 200 is 100. What do we have left? We have that P equal to 600. So 600 watts. Exactly 600 watts. So you just have to take note that power is equal to energy expended over time taken or work done over time. MGH. We have here a force of 20 Newton applied parallel to the horizontal moves a body through a distance of 40 centimeters. What is the work done by the force? Now the first thing you need to take note of is you are giving force to be 20 newtons. That's the first part. Then you are giving distance to be 40 centimeters. Now this distance is 40 centimeters, but we're going to convert this 40 centimeters to meters. We divide by 100, and this will give us 0.4 meters. Now if we have gotten 0.4 meters, we'll now say work is equal to force times distance. And what's force times distance? 0.4 times 20 times 20. If you check this now, it will give you 8. So the work now is 8 joules. You see the answer here now, 8 joules. That's how we got 8 joules to be the answer here. Take note. See how much work is done against gravity by a man whose mass is 70 kilogram in climbing a mountain of 2,000 height. So this is how we are going to do it now. We're giving the mass is 70 kilogram. Now the next thing is we're giving the height to be 2,000 meters. Now we don't need time in this aspect. The only thing we need is g, which is 10 meters per second square. So just take note that with the first part here, so we should find the work. So work is equal to mgh. So this is going to give us m, which is 70, times g, which is 10, times 2,000. So what we now have here, if you calculate it now, it will give you 1.4 million, I think so. If you check it very well, 0, 0, 0, 0, 0. We have 1. Okay, then when you divide it, when you now get this now, the answer is going to be in watts. The answer is going to be in joules, sorry. It's going to be in joules. But the problem now is that joules is now too big. So we need to divide by 1,000. When we divide by 1,000, we'll now convert it to kilojoules. So 1,000, from there we'll now have our work to be 1,400 kilojoules. And that's why you see in this place now we have 1,400 kilojoules as our answer. So that's how they call 1,400 kilojoules as the answer there. So we say a car of mass 800 kilogram attain the speed of 25 meters per second in 20 seconds. Calculate the power developed by the engine. Now just take note, remember that power is equal to work done over time. This work done now can also be energy expended over time. So in that case, if it is energy expended over time, this energy can either be potential energy or kinetic energy. And potential energy is mgh. Kinetic energy is half mv square. So that means if we are talking about power now, power is equal to energy expended over time. So the energy we are working with now in this question, if you check very well, we are giving m to be 800 kilogram. You check here now, you see we're giving velocity v to be 25 meters per second. We're giving time to be 20 seconds. So from what we have now, we can say that P is equal to and we're going to be using kinetic energy, so half mv square over t. So this will give us half times 800 times v square 25 times 25 over t, which is 20. So this will give us 2 here 1, 2 here 400, and when you now multiply this will give us now check this now, half mv square over time, half times 800 times 25 times 25. 2 into 800 is 400. 400 times 25 times 25 will give us 250,000 over 20. Now 250,000 divided by 20 will give us 12500. Now this 12500, we will now move our decimal points from here. 1, 2, 3, 4. How many do we have here? 10 raised to power 4. So that's why the answer is 1.25 times 10 raised to power 4 watts, as you can see here.